My favorite game as a child was hide and seek. And when I moved to university, I shared my passion and played hide and seek in many of the buildings across campus. E7, EIT, STC, awesome buildings to play hide and seek in. The main goal was to play hide and seek throughout the entirety of campus. However, when running these smaller scale hide and seek games, organization was really tough. And so organizing a large scale game throughout a large area and with a large number of players was going to be even tougher. I wanted a solution to help me scale up this game and to keep the competitive nature of the game to make it fun for all ages. This is where Pursuit comes in. We bring in the technology, we bring in the hide and seek, and we combine it together. The main thing we use is geolocation. In this Pursuit presentation, we're going to go through the project outline. We're also going to talk about existing competitors to Pursuit. We're going to talk about the legal and safety considerations of the game. We're, of course, going to go through a technical engineering implementation, as well as show a demo. And we're also going to show the results, the fruits of our labor. The result is Pursuit.
In terms of requirements and specifications, we wanted to have a smooth, intuitive, and interactive user interface. Also, a less than 1 second response time from any interactions with our backend server. This was so our user doesn't notice any lag or think that the application is clunky or anything like that. Additionally, support for transitions between Wi-Fi networks was quite important because if you're in a building and you're on their network and you move outside, you would switch to cell service, so ensuring that the game still works with that was quite important. Also, the ability to create and join lobbies was core functionality, the visual representation of players in the real world, marked by color-changing pins on the interactive 3D map, and the ability to be caught / end the game, paired with the leaderboard and passive scoring that would just happen in the background. Solution space exploration was us researching existing solutions and also hearing from other people, from user feedback about solutions that existed before that they had been using. So a few common ones that came up were Apple AirTags, sending screenshots of locations to each other on Google Maps, Find My iPhone app, and also a tracker app on the Google Play Store. So having said this, is Pursuit still worth it? And the answer is yes. So the other solutions don't really have periodic location updates, and that makes the game quite easy. You see a real-time dot moving at like a second interval pace, and that's quite easy to a seeker who's trying to find hiders. But the big thing with Pursuit is we have periodic location updates. So if a seeker is trying to find a hider, they see it every 30 seconds, or every minute, for example. So a hider can do a lot within that minute to kind of change directions completely and trick the seeker. Additionally, these solutions are not cross-platform, and generally they're clunkier. There's a higher barrier to entry, and you have to put in a lot of effort throughout the game. Take a screenshot, send it in the group chat, make sure all the times align between your friends. It's a lot more overhead and a lot more effort than many people would want to put in. So we believe that bundling this up and putting it into one package that is just ready to use out of the box, which is Pursuit, is a good way to go about this. Additionally, YouTubers with millions of followers play this game quite frequently, and in their comments and on social media, people actually want an app like this that they can interact with their friends with outside at a larger scale, so it's good to hear that as well.
This is a high-level overview for the Pursuit system design diagram. In our architecture, our front end is written in React as well as TypeScript. One of the main libraries that we use in Pursuit is the Map Libre library. It helps us gather relevant data from OpenStreetMaps, such as tiling, so that we could use to render the 3D interactive map that you do see in the front end. The front end is hosted on Netlify, and our Netlify front end, it communicates with our backend, which is hosted in an AWS EC2 instance. Our backend is written in Python and uses the Flask API library. It communicates with the front end by using HTTP requests and also communicates bidirectionally using WebSockets, using the Socket.io library. And this is what gives the information for what the actions in the game, such as when the users are caught and also sending the real-time user location data. Speaking of real-time user location data, this data is cached, never persisted, so that we do adhere to the user privacy guidelines. We also perform some analytics in the backend, as in we do log every users that visit our websites to gather user metrics for user testing. In the front end portion of this application, we're going to talk about a few things. But first off, I'm going to talk about the motivation for using a web application. The reason why we decided to go with a web tech stack is because we wanted to have a very low barrier of entry for players. We wanted players to be able to play no matter they're on Android, iOS, a tablet. We wanted everyone to be able to play Pursuit. And so the web application stack of React TypeScript was decided upon. The first thing we're going to talk about in the front end section is context state and how we're able to organize data cleanly throughout the front end. One of the big issues in React is that when you are using data in multiple places, you have to pass it around. However, when for something like a socket, which is used everywhere, it gets really messy when you're trying to pass things around, and you start passing data around in components that might not even need the data, but just due to the structure of React, that's just how it goes. A solution to this is to use context state. We are able to define a context in one spot, and we put all the data required to initialize that context, and it is this context state is used throughout the entirety of the application. This is an example of the context provider pattern, I believe, of the provider consumer pattern, where the provider or the state context is used by the consumers. So, for example, the socket context is shared with every component that uses it, which is the consumers. Places where we use context state include for sockets, as described earlier, for user data, anything related to the username, what lobby they're in, as well as the game, which had data on the actual game itself, such as the current player's location, as well as the current player's score. The next step, the next section of this is session caching. One of the downfalls with using a web application was that whenever a player would turn off their phone, they would lose their state associated with the game, just due to the nature of web applications. Another thing that was also an issue was if players ever disconnected, in that the whenever say a player was running around campus and they were on EduRoam, but the connection got spotty for a little bit, a player's socket would disconnect and they would also lose data associated with them. And so handling the networking and socket disconnects was a problem that we had to solve. How we solved this was we were able to cache user data as well as their socket in the front end as session data. And so if a user's socket would disconnect, say from their phone closing, or if their internet dropped, then the next time the player would reconnect, if a socket's data was established already in the front end session, then that means this data would be sent back to the backend, and the backend would update itself so that it's to accommodate for the new player's new socket information, and so the state of the game would return as normal. The next part that we want to talk about is map rendering, the last and final part. How the beautiful map for Pursuit is made is that relevant map tiles and map data are fetched from OpenStreetMap using Map Libre. After fetching these tiles in that these little pictures associated with the map, as well as any relevant map data, the map data would be rendered in 3D form with the map tiles. How we added the player coordinates on the back end, so where the higher little coordinate markers, or where the hiders are, where the seekers are, is that an SVG icon will be placed for every player in Pursuit, and that every player in Pursuit, or the back end, sends the coordinates of the player in terms of latitude and longitude, and so given the latitude and longitude, we would place the markers onto the map. Of course, hiders do not know where the seeker is. Hiders cannot see the seeker icon, and so the hiders can see the icons for all the other hiders are, but the seeker can see everyone's icon, including their own icon.
In terms of the backend, we use Python and Flask. So the backend is responsible for a few things, but it starts with lobby creation. So once you get to the home page, you create a lobby, you get an ID, you give that ID to your friends, they join that lobby, and now since you're all in, you can start this game. We can create data structures in the backend to kind of do all this game management. But once you've done this lobby creation, we move on to WebSockets. So this lobby creation is actually done through REST APIs. And then the remaining parts of the game are done through WebSockets. Because this is a persistent connection, we can save time by not killing a connection and then opening up, because that's a big overhead. All of the benefits of WebSockets are why we are using them. So we also use socket rooms. So if you join a lobby with 5 friends, those 5 front-end clients, that socket interaction will then be put into a socket room, and we have socket rooms per lobby. This helps for our next point, which is updating locations. So how the game actually works is that periodically the backend will broadcast a request client locations message to all of the front-end clients within a lobby. These clients will all respond with their GPS location, which is given to us after you allow location tracking in your browser. This is all anonymously sent back to the backend. Once the backend receives all of the locations of every client in that socket room or that lobby, then the backend can package this up into one location bundle of everyone's locations and then send it back to the clients. Because it sends it back to the clients, our front end will then render the new locations on the 3D interactive map. And that's how we do location updating in Pursuit. Of course, we have some policies in place that if not everybody sends their location, or maybe a request is dropped or something like that, the game will not break. But that's the general gist. Also, clean up on disconnect, endgame, scoring leaderboards, game state management, and analytics. Those are all functionalities that happen in our backend. Now moving on to deployments. So our front end is deployed with Netlify. Netlify was easiest for us because we just build the front end executable, drag and drop into Netlify, and it happens. It handles the rollout and then changing which application our domain pursuitgame.ca is pointing to. Our backend we chose to deploy in AWS as an AWS EC2 instance. This was just the easiest way to go, and it's protected by a load balancer that kind of routes it into the instance. Future scalability was one thought we had, and if we use EC2 instances, we can definitely make this quite scalable in terms of a microservice architecture with AWS ECS, which is the container service. So essentially we can put many EC2 instances in this kind of environment of containers. And yeah, that's what we chose to deploy with.
So our approach for the prototype and development process was to first, as a team, select a product or a feature with a very narrow scope that we thought was important in the process of developing our app. Once we had this selected, we would develop it and then reflect on it by trying it out as a team, and also reaching out to third parties that can try it out and let us know how they feel about it. Using all this feedback, we would then either decide to fully flesh out this feature or remove it, and then iterate on this process. This was great because it would give us really quick feedback on what we had been building, and help us guide our development process throughout the time that we worked on this project. So as an example, the first milestone that we thought important was to build a proof of concept and ensure that we can get real-time location updates using a simple UI on the web browser of a mobile device. We wanted to make sure that a human moving at like a little faster than walking speed would be able to give us actual movements on our map based on the precision of location that these devices collect. And after we were able to verify this, we developed a single public lobby so we could start playing the game and seeing how that would look. And then the steps after that were managing game state, integrating our 3D map, supporting private lobbies and making sure multiple games could be played at once, deploying this so we could have users play at scale and gather feedback at scale. And finally, we implemented a scoring and leaderboard system, which was highly requested by our users.
For our processes, it's quite straightforward. We use Git and GitHub for version control, Trello for project management, and one thing we were quite proud of was our smooth local testing pipeline. So if I wanted to test a change or I'm developing a feature, I would spin up my local front end with Node and my local backend with Python and Flask. And then I could use ngrok to have a public link that points to my local host front end. This was quite useful because if I needed to test with 4 or 5 people quite quickly, I could do this pipeline, give them the ngrok public link, and then it would be just as if I had deployed. PyTest for backend tests, Discord Messenger for communication, Google Drive for shared files, and we definitely realized we worked better synchronously. So we had weekly work sessions where we all were together and we could iterate quickly that way. In terms of future work, we want to set geographical game boundaries so it's not just the entire world as a boundary. Additionally, configurable timing for location updates. So if you think 30 seconds is enough, that's good. If you want 5 minutes to make it more of an intense game, or maybe it's larger scale, that's okay too. Additionally, displaying altitude differences. So if a person is on top of another person, but they're actually 6 stories up, how do you know that? One example solution would be to check like the radius. If this person is in the same radius as this other person, then maybe you can put a little notification saying, okay, this person is like 70 meters up or something like that. Additional game modes. One we were particularly excited about is the Hunger Games boundary shrinkage. So if you think about a boundary starting huge, over time it's going to become smaller and it'll end the game, make the game much more intense. Larger games are definitely fun. And one company partnership that we're trying to pursue is with Goose Chase. So Goose Chase is a company that hosts interactive experiences for corporations and additionally campuses. So if campus orientation were to happen and you're trying to ice break, they basically have a platform that has many games that fit that bill. And Pursuit would definitely be a great game hosted through their platform.
So I'll now be showing a demo of how you can start a game effortlessly. So here we are at pursuitgame.ca, where you can create a lobby or join a lobby. We also have a tips sections below. So we will create a lobby by entering our name, which will create a 4-digit lobby code that other people will join. Once people are in, we can start the game. Give it a few seconds for the first round of locations to come, and you will now see, boom, there it is. So the red is the hider and the blue is the seekers. This is just a quick game populated by a few friends around me. So I am the seeker here in red, whereas the blue represents the hiders. As you see the color hue switch, that represents a new location update. You can see here as I play around with the map that our map is a fully realized 3D map that supports rotating, zooming in and out, as well as spinning through various 2-finger drag moves. We can also see that once a hider is caught, there's an alert at the top that comes in live, and you can also see from that the number of hiders is starting to drop. So we'll have another showcase of that really soon as we continue to spin around and showcase this UI. We also have a proprietary scoring algorithm for which we generate a leaderboard based on how well each player does. So there's another one, Danny's been caught, and you will see the number of hiders will drop again, taking us to our game over screen once we run out of hiders. We'll now be moving on to a live demo or edited live demo of a real game I played with 3 other hiders. So 4 players total, which you can see by this current split screen. As I make my way up to a bridge, I notice that there is another, the first hider is somewhere on this bridge as well. So I'm able to chase him down, locate him, and catch him. Again, this is a showcase here that once a player is caught, every single screen is updated with a banner. The catching system in this game is honor-based, meaning that the hider screen has an I've been caught button, and the hider will self-report when they are caught. And we opted for this to avoid automatically catching people based on distance, so you can often hide in plain sight without the seeker actually knowing you. So right here, we're seeing I was able to catch hider number 2. That leaves hider number 3, the final one, remaining. Hider number 3 is going to kind of hide, and then from this we can see we can really showcase that 3D map view, giving us great orientation of roughly where hider 3 is. Jumping back to hider 3 here, where he will be hiding in line at Subway to kind of blend in with the crowd, but unfortunately that's not enough, and we are able to catch him. This was a ton of fun to film and a ton of fun to play, really showcasing the tools of our game.
So we had incorporated user feedback to help guide our development process from a very early stage. But once we had a version of our game that we thought was ready to be played by users as a complete game, we deployed it and then created this plan to conduct a user study. And the approach we here was to list out our goals and our claims for the app, and then ask relevant questions to users to verify whether we had achieved these goals, or whether there was some gap, and if so, where these gaps were. So our first claim was that Pursuit allows hide and seek to be played at a larger scale and also makes the game more competitive. And our goal was that through this, we would encourage many people to play the game and get more social and physical activity. Um, the method for our study was to obviously get users to play the game and then answer a list of questions through Google Forms or through an in-person interview when possible. Um, the obvious method for acquiring users was to or like one of the obvious methods was to share our game on social media, and have many people play it. We were slightly worried here, firstly by the noise that we might get from these results, and secondly the costs of deploying and supporting many users on this app. So instead, we had identified like many people being interested in our app throughout the development process as we chatted with peers about what we were building. So the first step was for us to host games with our friends, classmates, and people across campus that were interested. And we thought this was a good method because it allowed us to share a little more context, and sort of host games and scenarios that we wanted to test, and give us quality feedback. And then having these players who've already played with us host their own games with their friends, give a similar environment where there was always someone in the group who had already played the game before and could share this context with the new players or new users that were about to give us feedback. Um, some guidelines that we had, informed by TCP2 and other guidelines that we had referenced, are the following. So, firstly, we wanted to ensure that we had a transparent consent process. So, we wanted users to know exactly what they were getting into and what they were going to do through our user activity. This was done through like sharing it verbally when we hosted games, and we also have a few paragraphs at the top of our Google form explaining things like what our game is, what data we're collecting, what we're going to use the data for. Also, understanding that our users were going to be from a slightly limited network, we wanted to consider fairness, equity, conflicts of interest, and ensure that we had a very diverse audience that we were getting feedback from. Our surveys are also anonymous. They do not collect any identifying information. Identifying information from interviews was completely anonymized in our notes. The only caveat is some users shared their emails with us, in order to facilitate further discussion. And this was the only information stored, obviously at the consent of the user, and all of it was stored in Google Drive. Our data lifecycle was also very transparent. So we expressed that the data was only to be used for SE491 for the Capstone project. The raw data could only be viewed by Team Pursuit, members of Team Pursuit, and all the data was discarded at the end of the Capstone project or at the end of SE491. And we were quite happy with the results that we got. So since we deployed our app, until Symposium Day, we had over 500 players play our game, with over 150 lobbies created. And this is updated for today. We have 121 survey responses. And some of the positives are like majority of players had a better experience playing than hide and seek. Majority of them achieved an RPE of 2 or higher, which verifies that our app provides can provide some light physical activity. And 80% of players would play this game as a social activity with existing friends, and 60% would play the game at least once a month or more. And we were quite happy with this. There were a few negatives that we identified. Firstly, being many users expressed that they weren't comfortable playing this game with as an activity to make new friends. They would rather play with existing friends, and we thought this was quite fair. We also noticed that players would not choose this game as their first option to get some light physical activity, mainly because there's a lot of effort that goes into getting players and hosting a game. So players would rather do an easier option like going for a jog or a walk. So the light physical activity is something that comes as a byproduct of playing a game, but it wouldn't really be the reason that players would play the game. So this was some good. These were some good things that we learned based on our goal, based on the goals that we had for the app, and important considerations for future iterations. So data privacy and safety is important for application because we share and collect location data. So users consent to sharing their location for the duration of the game. It's only shared with other members of their private lobby. User location is identifiable by a username that's entered by the username, but it's anonymized when we share the location to other players because it's only associated with a randomized player ID. Um, Finally, game data is only stored for the duration of the session and no data is persisted. For legal considerations, we use a variety of open source technologies that all have compatible licenses with each other, and we credit OpenStreetMaps for the third party data usage on our app. In terms of future plans, we may maintain an open MIT license or work with a company who is interested in our app and then have a discussion with them on what to do with the copyrights and licensing of our app. Um, for physical safety considerations, currently our app just encourages players to be safe and aware of their hazards, and we only support private lobbies. In the future, we can improve the safety by having lobby verification and have the ability to see exactly who's in the lobby and even remove players. We can also have notifications for our app. For example, if we notice a player moving towards a busy parking lot or the train tracks, we can let them know that they're doing so and make sure they're aware of their surroundings while they're still looking at their phone and playing the game. Finally, we can recommend and flag verified safe places to play that are near the user's location. Just some examples of ways we can improve the safety of our game.